Yes, sir.
Lot of things was there to learn, right? Okay. So now I want to go for concept of electric flux. Electric flux. Okay. And electric flux is a measure of field lines passing through a given surface. So like if you have some surface like this, and there are field lines crossing the surface like this, and you take a small area, and this is the area vector. This is electric field. Okay, this is area vector. So let us write it as dA vector. So the flux is defined as if this angle is theta, its component this side will be E cos theta. So it is defined as E cos theta into dA. This is the definition of flux. So in a way, it is a measure of how many field lines are passing through this surface, this is small area. And if you want to calculate the flux total, it will be given by integral E dot dA. Correct? This is the flux. This is the definition of the flux. So it is a measure of number of field lines passing through unit area. Okay, number of field lines passing through unit area. ठीक है? Now the Gauss theorem that I am going to tell you is associated with this Gauss theorem. And Gauss theorem is if I write net flux as closed integral of E dot dA, so this will be equal to charge enclosed in that closed area over epsilon naught. This is the Gauss theorem. Okay. So this will be very helpful. This is actually always true because it is a mathematical concept. So it is always true, but not always helpful. So it's not always helpful because the purpose of Gauss theorem will be to calculate the electric field. Purpose क्या है? To calculate the electric field. So सिर्फ उन cases में ये helpful रहेगा जो कि easily integrable होंगे. Okay? So जो easily integrable situations होंगी उन्हीं में Gauss theorem अच्छे से मतलब you can apply it and you can get the electric field out of it. Otherwise, if it is not integrable, then even though it will be true, we can't apply it. We can't apply it to get any answer. ठीक है? Yes? और अगर मैं सबसे सिंपल केस लूं तो suppose we have a point charge like this and suppose I want to calculate electric field due to this point charge at this point, जिसका आंसर हमें पहले से पता है, that it is 1/4 pi epsilon naught q by r square, that we already know. Okay, so what we will do is the method is, so with this understand the method also. We will make a symmetric surface. Symmetric to what? Symmetric to the charge system. So because here the charge system is a point charge and the symmetry of point charge is sphere. अगर point बड़ा हो तो क्या बन जाएगा? Sphere बन जाएगा. So symmetry of the point charge is sphere. So that's why उस point से जहां तुम इलेक्ट्रिक फील्ड निकालना चाहते हो वहां से पास होने वाला एक सरफेस बना लोगे. Make a surface passing through that point where you want to calculate. So this is the point where we want the electric field. Where we want the electric field. So this will be the Gaussian surface. This will be Gaussian surface. Okay. So if you take a small area like this on this surface, so because of this, the field and area both are in same direction. Please see. The field and the area both will be in the same direction. So what will happen? What will happen? We will write the Gauss theorem, integration E dot dA is equal to Q enclosed over epsilon naught integral E dot dA is equal to Q enclosed over epsilon naught, and here theta is equal to 0. So that's why सबसे बड़ी बात है, बहुत ध्यान से देखना, E into dA is equal to Q enclosed over epsilon naught. Now, if you start taking this dA anywhere on the surface, because this dA has to be taken all over the surface if you want to cover the whole Gaussian surface, तो इस dA वाले पैच को हर जगह लेना पड़ेगा इंटीग्रेशन के टाइम पे. उस पूरे टाइम पे फील्ड की वैल्यू बदल नहीं रही है, because you know electric field is proportional to this q charge and inversely proportional to the square of the distance, और वो कहीं surface पे बदल नहीं रहा. So electric field is not changing, so that's why it will come out of this and it will become integral dA. This is a very very important thing to understand. अगर किसी situation में ऐसा है कि आप यहां से यहां जाओ गॉसियन सरफेस पे और इलेक्ट्रिक फील्ड की वैल्यू बदल जाए, तो उस केस में तुम गॉस थ्योरम को अप्लाई नहीं कर सकते. यू कांट अप्लाई गॉस थ्योरम. सो दिस हियर इट विल बिकम क्यू, आई मीन in that case Gauss theorem तो true रहेगा, but electric field will not come outside, so you will not get the value of electric field. This will become E into what is the surface area of the sphere, 4 pi r square over epsilon naught, and you know this will become 1/4 pi epsilon naught q by r square, and the direction of the field will be r cap. So this is something very very simple that I have done. Okay.
फील्ड की डायरेक्शन चेंज मतलब जैसे भी आउटवर्ड और इनवर्ड हो जाए तब नहीं काम करेगा ना?
आउटवर्ड से इनवर्ड हो जाए या फिर मैग्नीट्यूड भी अगर चेंज हो जाए तो भी नहीं काम करेगा, तब भी तो तुम्हें इंटीग्रल के बाहर नहीं ले सकते भाई. एक्चुअली ये क्या है, इंटीग्रल ई डॉट डी ए क्या है, सोचो. ये है एक्चुअली समेशन आई ई आई डॉट डी ए आई, यही तो है. हाँ भाई समेशन ही तो कॉन्टिन्यूअस सिस्टम में इंटीग्रल बन जाता है। तो अगर अलग अलग जगह एरिया ले रहे हो और इलेक्ट्रिक फील्ड की वैल्यू अलग अलग है, तो तुम ऐसे जोड़ना पड़ेगा सारे पैचेस को। इंटीग्रेशन की तरह तुम बाहर नहीं ले जाके जा पाओगे, समझ रहे हो?
यस सर।
सो इट विल बिकम लाइक दिस कि यहाँ E1 है फील्ड, तो यहाँ एरिया DA1 है प्लस डैश डैश डैश, ऐसे सबको ऐड करना पड़ेगा। तो अगर डायरेक्शन बदल जाए तो भी पॉसिबल नहीं है, और अगर मैग्नीट्यूड बदल जाए तो भी पॉसिबल नहीं। तो
Sir,
यस।
sir, sorry to disturb you, sir. Can you tell in
नो नो नो,
English?
अरे भाई, व्हाई यू आर
Sir,
सेइंग सॉरी टू डिस्टर्ब?
like I cannot follow Hindi too much,
हाँ,
so
that is okay, that is okay.
yeah,
I told you that in English also,
yeah,
but
okay.
somebody asked question in Hindi na, so that's why.
Okay, sir.
हाँ, which thing you did not understand?
No, I can follow Hindi, but I'm
No
too
no no,
slow in.
right now what you could not understand?
So he asked a question, right? So that
He
question I
asked a
wanted to answer.
question. He asked a
I didn't
question
get it.
that in what case I will not be able to use this Gauss theorem
Okay.
to calculate the electric field. So he said if the direction reverses, suppose I am going like this and suddenly the field changes the direction because suppose
Okay.
some charge configuration changed. So then
Okay.
also I can't apply because the field cannot be taken out of the integral. And at the
Okay.
same time, if even the magnitude changes, suppose here it is E1 and here it becomes E2. So that I
Okay.
explained that
Yeah.
if I take here EI, so
Okay.
only thing is we can add it like this. It won't
Mhm.
go out of the summation or out of the integral, and the field value we will not be able to solve.
Okay, sir, got it.
So practically isko chote chote in small areas we have to make small patches, then get all the fields and then take vector sum. Okay, so it will become a problem of numerical technique. ठीक है?
Okay, sir.
तो is it okay कि किस केस में लगा सकते हैं? Everybody understood?
यस
Yes,
सर।
sir.
Okay. So we are इसको हम लोग क्लास 12th से पढ़ रहे हैं. We are reading this since our class 12th. So we are so used to of taking electric field outside that sometimes even we don't see whether field is having the same magnitude, same direction every time we move on the Gaussian surface or not. But हम लोग को इस बात का ध्यान रखना होगा. Okay. So now to begin with, let us take some basic structures and let us apply Gauss theorem to it. Huh? So let us take some basic structures. So the first one will be, suppose there is infinite line charge distribution lambda. Please understand why infinite is important. Infinite length of thin wire having charge density lambda. So infinite wire for infinite wire we can calculate because the wire will have a symmetry of cylinder. So I will draw a cylinder as a Gaussian surface. And Gaussian surface always passes through the point where we want to calculate the electric field. So this is the situation. अब ध्यान से समझना इस बात को. If this wire is short, then this patch will have different field, and if I move this patch here, it will have a different field. देखो ये बात समझ पाते हो सभी लोग?
यस सर।
But if this wire is infinite, then no effect of moving on the Gaussian surface. This is very important. Sometimes we don't give importance to this concept. So this will be the electric field and dA vector, and both are in this direction. Yes.
तो शॉर्ट लेंथ होगी तो कैसे?
भाई अगर मान लो ये वायर शॉर्ट हो जाए, सिर्फ इतना है,
Yes, sir.
तो इस वायर में यहाँ पे फील्ड और यहाँ पे फील्ड में फर्क होगा। आपने कैलकुलेट तो किया है थिन वायर की, शॉर्ट वायर की वजह से इलेक्ट्रिक फील्ड
Okay, sir.
किया है या नहीं किया है?
Yes, sir.
ये वायर ऐसे किया है ना, यहाँ पे इलेक्ट्रिक फील्ड, ये दोनों ऐसे थे, याद नहीं है?
Yes, sir. Yes.
तो एंगल्स चेंज करने पे बदल नहीं रहा था, एंगल मींस पोजीशन, तो बदल जा रहा था उससे, राइट? परमप्रीत क्लियर है?
Yes, sir.
So let us apply Gauss theorem. So closed integral E dot dA is equal to Q enclosed over epsilon naught. Now this Gaussian surface should be a closed surface. So one surface is this curved surface and two surfaces are this and this. So this integral will be broken into this, then a small area you should take here, and then a small area you should take here. So let us call this as dA2. Let us call it as dA3. But the problem is that the electric field will be perpendicularly outside. Correct? There will be no component of the electric field. So for this, the field is this side. So the angle is 90. So this will not contribute. So only this one will contribute. So it will become E, and E will be same everywhere. E into 2 pi r L. Let us take L as a length of the Gaussian cylinder. And this will be equal to charge इसमें कितना enclosed होगा, lambda L over epsilon naught. L and L will cancel. So E will be lambda by 2 pi epsilon naught r and r cap. This will be the electric field. सभी लोग देखो ध्यान से. Are you understanding? So that means if I plot a graph, this is suppose O, and this is distance r. So the field will go like this. This will be the direction of the field. And left hand side, if you go, it will go like this. Okay. This will be the field. Because electric field will go like 1 by r. Here theta is 90. Here also theta is 90. So cos 90 will be 0. इसलिए no contribution to the flux. So I am now discussing the topic applications of Gauss theorem. This is the first one. Applications of Gauss theorem. ठीक है? सबको क्लियर है? Clear to everyone?
Yes, sir.
मिटा दूं?
Yes, sir.
Now let us take sphere. Solid sphere. R is radius, rho is charge density. So if I take a solid sphere like this and let R is the distance and rho is charge density. Rho is charge density. So let us take a small distance R and we want to calculate the electric field at this point. So let us draw a closed surface. This will be a Gaussian surface. So this is solid sphere. Solid sphere. And this is the Gaussian surface. This is a solid sphere and this is the Gaussian surface. ठीक है? So again, at this point, take a small area. So dA and field will be also in the same direction. So if you write integral E dot dA, it will be Q enclosed over epsilon naught. Again, theta is 0 and E is constant. If you take E anywhere on the Gaussian surface, it is constant. So E into 4 pi R square is equal to 1 by epsilon naught Q enclosed. So Q enclosed will be 4 by 3 pi R cube upon 4 by 3 pi R cube into Q. This will be the charge enclosed by unitary method in this. इसमें कितना charge होगा? So this will cancel. This will cancel. So E will be how much? 1 by
1 by 4 pi epsilon
4 pi
naught
epsilon naught
Q into R
Q R by
R cube.
R cube. So check this dimensionally also. So the electric field is 1 by 4 pi epsilon naught Q by R square, because this is meter square. So meter cube. So it will be meter square. ठीक है ना? तो इस तरीके से आप चेक भी कर सकते हो. और इसी को if you want to write in terms of rho, it will be rho R by 3 epsilon naught. This will be the electric field, rho R by 3 epsilon naught. So if you plot a graph, how it will look like. So electric field यहाँ 0 है. और जैसे ही center से आप बाहर निकलोगे, तो it will increase because it is proportional to small r. At capital R, it will become maximum and then it will fall like this. So here it will be E1 by R square outside. So let me calculate outside. So if for outside you take a point P here, this will be the Gaussian surface. So E into 4 pi R square will be, total charge will be Q by epsilon naught. So E will be 1 by 4 pi epsilon naught Q by R square. और Q को चाहो तो रो के टर्म में लिख दो, because rho is Q by 4 by 3 pi R Q, charge by volume. ठीक है? Is it okay? सबको समझ आ रहा?
Yes, sir. Yes, sir.
किसी को कुछ पूछना हो इसमें तो पूछ लो, otherwise I will erase this.
अरे आउटसाइड के लिए बड़ा वाला स्फीयर गॉसियन सरफेस माना ना हमने।
जिस पॉइंट पे निकालना है उस पॉइंट से तुम्हें गॉसियन सरफेस को गुजारना है. The Gaussian surface will pass from the point where you want to calculate the electric field. क्या क्वेश्चन है आपका? तो आपको यहां पे एक छोटा एरिया लेना होगा और यहां पे इलेक्ट्रिक फील्ड E, DA लिखना होगा. इलेक्ट्रिक फील्ड और एरिया. हाँ, क्या पूछ रहे हैं?
यही पूछ रहा था।
चलो मिटा दूं फिर, सबको क्लियर है?
Yes, sir.
तो नेक्स्ट कैलकुलेट करते हैं hollow sphere of radius capital R and charge density sigma. Okay. So if you take a hollow sphere like this of radius capital R, center O. So if you take a point which is inside R less than R, then you will take a point P here and draw a Gaussian surface like this. This is sphere. This is the Gaussian surface. Huh? So you take a small area again here and then E, DA. Yes. So closed integral E dot dA is equal to Q enclosed over epsilon naught. So E into 4 pi R square is equal to 0 by epsilon naught. So E is equal to 0. So inside the shell, the field will be always 0 because there is no charge enclosed. So inside the shell, the field will be 0. Okay. And if you take R greater than R, so you will go outside here. Then again you will draw Gaussian surface. So you will write E into 4 pi R square is equal to Q by epsilon naught. So the field will be 1 by 4 pi epsilon naught Q by R square. और in terms of sigma क्या होगा? Because sigma will be Q by 4 pi R square. So Q by 4 pi R square, so it will become sigma by epsilon naught. This will be the field. So one thing also I want to tell you that if this is the sphere, this is the perpendicular surface on the sphere. Yes or no? This radial vector is perpendicular. And field, electric field, this is the surface. इलेक्ट्रिक फील्ड का जो परपेंडिकुलर कंपोनेंट होता है अबव माइनस परपेंडिकुलर कंपोनेंट बिलो इज सिग्मा बाय एप्सिलॉन नॉट. किसी भी सिस्टम के लिए दिस इज ट्रू. दिस इज डिराइव्ड यूजिंग गॉस थ्योरम. तो यहां पे भी देखो अबव आई एम सॉरी ये क्यू बाय आर स्क्वायर लिखना पड़ेगा ना. R square. So 1 by Q by 4 pi R square will become sigma, and it will become sigma R square by R square. Okay. So this is small r. Small r is for the distance and capital R is for the. So if you take the profile here above and come on the surface, so small r will become capital R. So it will become sigma by epsilon naught minus, if you go below, inside field is 0. So therefore it is following sigma by epsilon naught. Perpendicular component. And parallel component is always continuous. Parallel. This is always equal. So here parallel component is 0. 0 is equal to 0. So E perpendicular means perpendicular to the surface. This is the surface. ये देखो ये समझ आता है सबको. Discontinuity of electric field. Perpendicular component is discontinuous and parallel component is continuous. Yes.
सर आउटसाइड इलेक्ट्रिक फील्ड में जो आपने वैल्यू रखी 1/4 पाई एप्सिलॉन नॉट कैपिटल R स्क्वायर और इनटू Q इनटू कैपिटल R स्क्वायर, सर वहां हम R स्क्वायर कैंसिल नहीं कर सकते?
यहाँ क्या आया था? E is equal to 1/4 pi epsilon naught Q by R square. ये आया था.
ओके.
तो मैं इसको सिग्मा के टर्म में लिखना चाह रहा था, तो इसलिए मैंने R स्क्वायर से डिवाइड और मल्टीप्लाई कर लिया था.
सर ये above and below वाला नहीं आ रहा समझ.
ये इलेक्ट्रिक फील्ड है.
यस सर.
ये पॉइंट है ऑन द सरफेस. तो दिस इज सरफेस. सरफेस के अबव वेरी वेरी क्लोज ये पॉइंट है, और सरफेस के बिलो वेरी वेरी क्लोज ये पॉइंट. दीज पॉइंट्स आर वेरी वेरी क्लोज. सो अबव मींस क्या हो गया? आउटसाइड. above is outside and below is inside. So outside field profile is this, but since it is very very close, small r is equal to capital R. So outside profile will become sigma by epsilon naught. And inside field is 0, so minus 0. And this should be equal to sigma by epsilon naught, which is true. Parampreet, अब बताओ.
Yes, sir.
So ये बहुत बड़ी बात है कि for this is true for any surface. If there is any surface, then the perpendicular component of the field will have this E perpendicular A minus E perpendicular below B will be equal to sigma by epsilon naught. You can check
Sir,
it for the previous case of sphere also and cylinder also.
सर ये जैसे क्लोज हमने लिया है तो हमने मतलब ये तो फॉर दिस एग्जांपल ले लिया, अगर दूर भी होगा तब भी ये ट्रू होगा.
नहीं, दूर कैसे होगा? सरफेस पे है ना ये अप्लाई हो रहा.
ये अबव परपेंडिकुलर ना, अबव
Perpendicular above means above the surface.
above the surface. Yes, above the surface. अगर my question is अगर point दूर होगा तब नहीं होगा.
No.
Means
Okay,
point
sir.
should be
Sir,
close
it
to
means it is only verified for the surface which is closer.
No. Surface is the surf. What is the surface here?
The point which is closer to
No.
the surface.
What is the surface here?
Gaussian surface.
Surface? No, not Gaussian surface. Absolutely wrong. Surface is the sphere.
Surface of sphere.
Yes.
Surface is the sphere. So this is the surface. That's why मैंने उसी पे tangent बना दिया है. This is the surface. So just above means very, very close. Just below means very, very close. So it is almost on the surface, the discontinuity. Okay? So that's why ये मैंने बनाया है. ये surface है. And suppose this is the component of the field.
तो फिर हम ऑन द स्फीयर ही ले ले, ऑन द सरफेस ही कर लेते हैं इसको समझने
तो
के
ऑन द सरफेस में दो प्रोफाइल है ना, नीचे कुछ और है, ऊपर कुछ और है. सो इसीलिए जस्ट ऊपर जाने की बहुत वैल्यू है.
ओके.
अंदर फील्ड 0 है, बाहर फील्ड फाइनाइट है. तो अगर तुम ऑन द सरफेस हो तो कौन सी फील्ड लोगे बताओ?
यस ओके.
यहां फील्ड
Just
0
above.
है, यहां फील्ड है सिग्मा बाई एप्सिलॉन नॉट, आर स्क्वायर बाई आर स्क्वायर, यही है ना?
Yes.
तो अगर तुम ऊपर और नीचे का डिस्टिंक्शन नहीं करोगे तो तुम कौन सी फील्ड प्रोफाइल लोगे? ये बहुत कम लोग समझ पाते हैं बाउंड्री कंडीशन. ये नहीं पता है कि बाउंड्री क्या है. बाउंड्री मींस द सरफेस. सर व्हाट इज द सरफेस? गॉसियन सरफेस का रोल दैट इज इमेजिनरी सरफेस जस्ट टू कैलकुलेट इलेक्ट्रिक फील्ड. once you get the electric field, the role of Gaussian surface is gone. Now you have something like this. Let me erase all this.
Sir, this perpendicular condition is for all the surfaces.
All the surface. यही तो बहुत बड़ी बात है.
Yes, sir.
This is true
And-
for any surface. Why?
and sir-
Because this is derived from Gauss theorem, and Gauss theorem is true for any surface.
Okay, and parallel wali condition is also valid for all the
Also
surfaces.
valid for every surface.
Okay, sir.
ये आप लोगों ने पढ़ा भी होगा, ऐसा थोड़ा नहीं पढ़ा होगा. So suppose you had sphere. स्फीयर था ना अभी. स्फीयर पे सरफेस ले लो कोई. ये सरफेस हो गया. दिस इज द परपेंडिकुलर. तो ई परपेंडिकुलर अबव बताओ कितना होगा?
वन बाय 4 पाई एप्सिलॉन नॉट क्यू बाय आर स्क्वायर.
1/4 पाई एप्सिलॉन नॉट क्यू बाय आर स्क्वायर. कैपिटल आर क्यों लिख रहा हूं?
Point is close.
Because we are just above the surface. Okay?
यस सर.
So इसको जरा सिग्मा के टर्म में लिखो. सॉरी, रो के टर्म में. कोई बात नहीं. Let me write it like this. Okay? E perpendicular above. E perpendicular below क्या होगा? Because दोनों को compare.
3
How
एप्सिलॉन.
we E perpendicular below is 1/4 pi epsilon naught
क्यू स्मॉल
Q R by
बाय आर क्यू.
R cube. So E perpendicular above minus E perpendicular below should be sigma by epsilon naught. यही तो बताया मैंने. So E perpendicular above minus E perpendicular below, because there is no sigma here, so that's why it is 0. अब चेक करो यहाँ पे 1 by 4 pi epsilon naught q by r square minus 1 by 4 pi epsilon naught q by r square is equal to 0. आ गया या नहीं आ गया? So in this system we had rho, no sigma when we calculated the field. Follow कर रहा है ना? डाउट आए तो पूछ लेना भाई.
Sir,
Hmm.
my question is this, that this statement is only valid for the just above and just below the surface.
That is a wrong question.
Sir, what mean?
Tell me why your question is wrong.
Sir, when
Because the discontinuity, see, if you have something like this, suppose there is a sphere and you are moving like this, okay? So you are and this is the surface, because this is separating two mediums. This is medium 1, this is medium 2. Yes or no? So when you
Yes.
are moving, you only encounter the surface here. So when I am saying that there is a discontinuity of electric field, when you move from here to here, there is a discontinuity. Suppose this perpendicular, this was 0 everywhere, that means it was continuous. That means E perpendicular above was equal to E perpendicular below. But when I am saying there is a discontinuity, means here value is something different and here value is something different. And that difference is given by this. यही तो बोल रहा हूं. So because this is the property, when you pass this surface, this continuity is there. So that's why you will always apply it on the surface, one just above the surface and one just below the surface. So where is question of applying it here, where there is no surface? यहाँ कोई surface है ही नहीं, तो वहां apply कैसे कर सकते हो? समझ में आ रहा है बात या नहीं? बोलो नेहा. What is your name?
Nayan.
हाँ Nayan. Nayan.
Yes, sir.
So you can't apply it here. Here there is no surface by.
Yes, sir.
हेलो
ये
सर,
अपने आप में
हाँ
जैसे
बड़ी
मैं ये
बात है ये।
बोलो भाई.
हेलो, हाँ
हाँ
सर,
बोलो.
जैसे मैं इनफाइनाइट वायर के लिए मैं लगा रहा था सर इसको, तो इनफाइनाइट वायर के लिए जब मैं सिलेंडर से के
अरे अब
सर्कल
रुक
से
जाओ ना,
थोड़ा,
जब मैं लगाने जा रहा हूँ तो वो क्यों डिस्कस कर रहे हो?
ओके सर,
इसमें जो प्रॉब्लम है वो बताओ. ये ठीक है?
हाँ सर ये ठीक है
तो वो तो बताने ही जा रहा हूँ, तो फिर उसको पहले से डिस्कस करने का क्या फायदा है?
सर, वो मालूम नहीं था आप तो करने वाले हैं.
हाँ कोई बात नहीं. तो 2 मिनट वो भी देख लेते हैं जल्दी से. तो it was this was the cylinder, this is the surface, huh? Here surface is this, right? This is the perpendicular. So what is field here? Tell me, Varun. Lambda by
2 pi
टू एप्सिलॉन
epsilon
नॉट.
naught r.
capital R. What is the field here?
Lambda by 2 pi epsilon naught is not.
No, you are talking about thin wire. I calculated it for thin wire, na? So thin wire, there is no inside or outside. For this, we will have to do thick wire. Okay. ठीक है, Varun?
Yes.
If you need a surface, then you take a thick wire, long thick wire, like this. And suppose this is having radius capital R, okay? And this is having charge density rho. Now, this ye kya hai? What is this?
Infinite.
This is infinite thick wire.
Axial line.
This is axis, bhai. And what is this? Kanchan. This is thick wire. Okay. Now, if you want to calculate the electric field inside, just draw a Gaussian surface passing through this point. So I will write R less than R. So it will become, bolo, E into 2 pi R L will become, how much charge will be contained in it? इसमें कितना charge होगा? Sigma or rho into pi R square L by epsilon naught. Check करना, कोई doubt होगा तो बताओ. So pi L R R. So field will be rho R by 2 epsilon naught. Cylinder में अंदर कितना था? Solid, thick wire. What was for sphere? Rho R by 3 epsilon naught. What is for cylinder? Rho R by, sorry. In sphere, it was rho R by 3 epsilon naught. What is for cylinder? It is rho R by 2 epsilon naught. Yes or no? समझ आ रहा है? And if you go outside, then you have to take Gaussian surface here, here. Then you draw a cylinder like this. Like this. This will be the Gaussian cylinder. So for R this, it will become E into 2 pi RL is equal to, what will be the charge contained? How much charge will be there? Rho into, bolo bhai, pi R square L over epsilon naught. So E will be equal to pi LL. E will be equal to rho R square by 2 epsilon naught R. This will be outside. So in this case also, if you draw the field, it will increase inside and then decay outside. Because here it will be proportional to R and here it will go as 1 by R. Correct? अब लगाते हैं. तो अब मुझे नयन बताएगी कि where is the surface? बताओ भाई.
Sir, at R distance from the axis,
Which R?
small r.
No, not at
No,
all.
no, sir, capital R.
Where is surface at small r, bhai?
There is small r, Gaussian
there is
surface.
no that is Gaussian surface. That is not a
Yes.
surface. No?
Yes,
So here you have a surface, right?
at capital R.
So
Yes.
draw perpendicular. get field here, get field here. Subtract them, you will get sigma by epsilon naught. Let us do that. So what is outside? This is the field. कितना आएगा? Rho r by 2 epsilon naught minus what is inside? Rho
Rho r by
r by 2 epsilon naught, and that becomes equal to 0. Why? Because there is no sigma in this case. देखो सबको समझ आ रहा है? So this is the perpendicular boundary condition which will always work. We will do it again when we will study dielectrics. It will become very important. We'll do it there in detail. But let us start understanding it from here itself. किसी को भी कुछ पूछना है तो पूछ लो. So if you calculate field here, this distance is about capital R. If you calculate field here, this distance is also about capital R. Okay? Clear है?
yes sir.
Yes, sir.
और लोग बताओ भाई, बाउंड्री कंडीशंस समझ आ रही हैं? Lakshmi,
Yes, sir.
Meenal, you can ask if there is any doubt.
सर ऐसे पैरेलल की कैसे आएगी, मतलब निकालना होगा.
So this is perpendicular to the surface, and parallel to surface means, so see, this is the surface. So perpendicular means this field this side, and parallel means field this side, this side. So because there is no parallel field here, so 0 minus 0 is equal to 0.
Okay.
So for parallel, 0 minus 0 is equal to 0. Okay? But in the cases where field will be there, parallel field, we will take care of that. Pooja, समझ आ रहा है? हर्षित?
जी सर, आ रहा है सर.
आ रहा है. चलो, वेरी नाइस. तो बाउंड्री कंडीशन का कॉन्सेप्ट थोड़ा क्लियर हुआ, राइट?
Yes, sir.
सर जब 0 आ रहा है माइनस, तो इट मींस कॉन्टिन्यूस फील्ड.
हाँ, अगर 0 आ रहा है तो मतलब सेम. अरे ये इतनी सिंपल सी बात है भाई, इसको इतना टफ क्यों लेते हो? ये सरफेस है, यहाँ पे तुम चलते हुए आ रहे हो 2 है वैल्यू, यहाँ चले गए 3 है, तो ये डिसकंटिन्यूटी है. ये सरफेस है, यहाँ भी 2 है, यहाँ भी 2 है, ये कंटिन्यूटी है. तो ये डिसकंटिन्यूटी है क्योंकि 3 माइनस 2 इज इक्वल टू 1. ये कंटिन्यूटी है बिकॉज 2 माइनस 2 इज 0. तो कंटिन्यूअस मींस सेम, डिसकंटिन्यूअस मींस डिफरेंट. ओके?
यस सर.
ओके? तो हम लोगों ने स्फेयर कर लिया, सॉलिड सिलेंडर कर लिया. नाउ let us come to sheet, infinite sheet. So this is infinite sheet. So infinite sheet, suppose the charge density is given to be sigma, that is spread all over it, like this. Charge is spread over the sheet. Okay. So now in this case also, because sheet is infinite, so if you take a Gaussian surface like this cylinder, suppose I wanted field here at this point P. So that's why I took a cylinder passing through this, and it is going this side also, like this is the cylinder. Okay. Again, this is the point where you want electric field. So cylinder is like this. So it will be cutting this. ये नजर आ रहा है आपको? Imaginary surface है, going like this. So field is in this direction. So on this cylinder, here field is in this direction. dA is in this direction. Here dA is in this direction. And one dA I will have to take this direction, but it will not contribute because with electric field, the angle will be 90.
90 degrees.
So when you take closed integral E dot dA is equal to Q enclosed over epsilon naught. Now this is a closed Gaussian surface. So E dA means dA का इंटीग्रल क्या हो जाएगा? Suppose this area is capital A. E into A plus E into A of that side is equal to Q enclosed कितना होगा? Sigma into A, because here how much charge will be there in the Gaussian surface? How much charge is enclosed here? Charge density into area over epsilon naught. So area will be cancelled. So field will be equal to sigma by epsilon naught. N cap. Suppose this direction is n cap. This is the field. अब बड़ी मजेदार बात है कि if I make this surface as this perpendicular surface, ऐसे बना देता हूं. दिख रहा है ये?
It will sigma upon 2 epsilon naught, na?
Sigma by 2 epsilon naught. ऐसे बना दूं अगर, this is the plate. Is it okay? Infinite plate?
Then cylinder
Yes.
भी rotate होगा.
है वरुण? क्या कह रहे हैं?
सर ये perpendicular आ जाएगी.
हाँ,
जैसे
perpendicular.
आपने, हाँ, तो सर
जैसे-
सिलेंडर भी रोटेट हो जाएगा.
अरे यार, सिलेंडर छोड़ो, सिलेंडर का काम खत्म हो गया, फील्ड निकल आई.
यस सर, यस सर.
अब सिलेंडर के
गया, सर.
ऊपर ही बैठ जाओ तुम.
सर वो थोड़ा सा टफ है.
क्या टफ है?
सिलेंडर के ऊपर बैठना.
क्यों? झूला है. ओके, इट्स लाइक अ स्विंग. ऐसे देख रहे हैं?
यस सर.
सो फिर से मैंने बोला E perpendicular above. So E perpendicular above is sigma by 2 epsilon naught n cap minus E perpendicular below. Below field कैसी है? इधर है. Sigma by 2 epsilon naught. है इधर या नहीं?
Yes, sir.
So if this is the n cap direction, I will have to write it as minus sigma by 2 epsilon naught minus n cap. Yes or no?
Yes.
And this will be equal to sigma by epsilon naught. You know that. So sigma by epsilon naught is equal to sigma by epsilon naught. आगे ना वो discontinuity यहाँ भी exist कर रही है. So the boundary condition which you learned, that E perpendicular above minus E perpendicular below is equal to sigma by epsilon naught, that is happening here also. वरुण देखो, समझ आ रहा है?
यस सर.
समझ आ रहा है?
सर ये थिन शीट थी ना,
थिन शीट।
अगर इसी की जगह पे थिक शीट होती तो उसके लिए ये कंडीशन वैलिड होती क्या, बाउंड्री कंडीशन परपेंडिकुलर वाली?
बाउंड्री कंडीशन जब मैंने एक लाइन में आपको बोल दिया इज ऑलवेज ट्रू,
नहीं उस केस
बिकॉज
में हमारे
दैट
पास सिग्मा
कम्स
की
फ्रॉम,
जगह रो होता ना सर, अगर ये थिक शीट होती
तो
तो चार्ज डेंसिटी सरफेस की बजाय अगर हम वॉल्यूम डेंसिटी भी तो ले सकते थे, वॉल्यूम चार्ज डेंसिटी।
आप अभी क्या चाहते हो कि थिक शीट डिराइव किया जाए?
यस सर, थिक शीट
वो
के
तो
लिए।
करेंगे ही डिराइव, तो आपको कहने की जरूरत नहीं पड़ेगी। आप जब पूरे सेट ऑफ प्रॉब्लम्स देखोगे सब कुछ डिराइव होगा, बट वो तो एक साथ नहीं हो सकता ना।
यस सर,
लेकिन एक लाइन में आपको क्या समझना है पहले?
कि अगर इसकी थिन की
नहीं नहीं,
जगह पे।
ये सब छोड़ो। बाउंड्री कंडीशन इज ऑलवेज वैलिड,
ओके सर।
तो उसका क्वेश्चन हटा दो दिमाग से। कोई भी केस है, इट इज ऑलवेज ट्रू।
यस सर।
हमें क्या समझना है कि कैसे अप्लाई करें कि हमें दिखे कि वो ट्रू है। तो
ओके
दोनों
सर।
बातें अलग अलग है ना।
यस सर।
उसके ट्रूथनेस पे कोई प्रॉब्लम नहीं है, दैट इज ऑलवेज ट्रू। नाउ वी हैव टू सी इन एवरी केस दैट इट इज फॉलोइंग। ओके।
ओके सर।
अब ये इनफाइनाइट शीट की बड़ी मजेदार बात ये है, तो बिल्कुल थिन शीट अगर ना होती तो ये मैं कैसे ऐसे लिखता, क्यू इनक्लोज सिग्मा बाई एरिया।
No.
नो सर।
समझ रहे हो? तो ऑब्वियसली इट इज अ थिन शीट, राइट? सो a very important point about this infinite sheet is that it gives a uniform field. So this was infinite sheet, and you found that sigma by 2 epsilon naught here, it is independent of distance. Abhi tak whenever you calculated the field, it was depending on the distance, but in this case it is independent of the distance, right? Why this is happening is that when you are calculating field here, suppose this much of the charges will contribute alpha. So this much of charges will contribute because what is happening, इस वाले charge का जो contribution है, that will come towards this as this angle alpha, right? Whatever is this angle alpha by 2, it will be contributing towards this. So जैसे जैसे alpha बढ़ता जाएगा, cos of alpha छोटा होता जाएगा, so दूर वालों का contribution कम होता जाएगा. So let us take that the contribution is up to the angle alpha. Okay. So if you go far, suppose here, and suppose same angle alpha is contributing, so this will become bigger. So the field that should decrease will not decrease. So that's why here sigma by 2 epsilon naught, and here also sigma by 2 epsilon naught. So this is the explanation why for infinite sheet the field is uniform. समझ आया?
Please repeat this.
मैं ये कह रहा हूं कि इसमें चार्ज है ना पूरे शीट पे, तो सारे चार्ज इस पॉइंट पे फील्ड क्रिएट करेंगे। मान लो तुम यहां फील्ड निकाल रहे हो, तो अगर तुम दूर चले जाओ तो वो जो फील्ड होगी वो ऐसे आएगी, और तुम इसका कंट्रीब्यूशन इस तरफ देखोगे तो कॉस अल्फा कंपोनेंट लेना पड़ेगा। क्या लेना पड़ेगा? कॉस अल्फा। तो जैसे से दूर जाओगे अल्फा बड़ा होता जाएगा और कॉस अल्फा छोटा हो जाएगा। एज अल्फा इंक्रीजेस कॉस अल्फा डिक्रीजेस। आर यू गेटिंग इट और नॉट? तो तुम एक पॉइंट के बाद यू विल से कि अब वो कंट्रीब्यूट नहीं कर रहा, उसको छोड़ दो, तो दैट एंगल आई हैव टेकन अल्फा। तो अगर मैं इतने मान लूं कि ये अल्फा एंगल तक कंट्रीब्यूशन मिल रहा है मुझे, तो इफ आई गो फार तो फील्ड घटनी चाहिए, but because of the same angle alpha, more charges will come into the picture and they will increase the field and make it the same. तो जितनी फील्ड यहां थी उतनी ही फील्ड यहां भी रह जाएगी। ओके?
Sir, I have a doubt.
Hmm.
So generally, practically, when we are checking, when we are moving away from the sheet, electric field should decrease, right?
But because the sheet is infinite,
Okay.
and I explained you कि once you go far, more and more charges come into picture for the same angle alpha.
Okay.
So
Okay.
they compensate for that. What is your question?
Yeah, got it, sir. That's the same thing. Yeah.
Okay. So this is very nice explanation. Okay. Yeah. Thank you so much.
सर बट ये सच में बहुत यूनिक बात है सर, इलेक्ट्रिक फील्ड यूनिफॉर्म देखने को नहीं मिलती।
क्या यूनिक बात है?
सर की इनफाइनाइट शीट के लिए यूनिफॉर्म इलेक्ट्रिक फील्ड आ रही है।
हाँ बिल्कुल, और उसका एक्सप्लेनेशन और यूनिक है
सर।
तो फील्ड ऐसे आ रही है, सिग्मा बाई एप्सिलॉन नॉट इधर आएगी और इधर सिग्मा बाई एप्सिलॉन नॉट, और ये 2 एप्सिलॉन नॉट, सॉरी, और इसलिए ये जंप है, डिसकंटिन्यूटी। ये है डिसकंटिन्यूटी, देखो जिसको समझ नहीं आ रहा।
यस सर।
दिस इज द जंप। सो ये कितना है? सिग्मा बाई एप्सिलॉन। और किसने पूछा था एम से नाम है? लेट मी सी। एम मीनल, कई लोग हैं एम से भाई। अभी अभी जिन्होंने पूछा, हाँ मनीषा।
यस सर।
ये कब, ये डिसकंटिन्यूटी का अमाउंट है ना?
यस सर।
तो ये किस केस में होगा?
थिन शीट वाले केस में सर। मतलब
पूजा,
इन एनी केस,
in any case, because
above perpendicular और below perpendicular।
मनीषा देखो, ये है डिसकंटिन्यूटी का अमाउंट। सो किस केस में ये होगा?
हाँ, ये हर केस के लिए ही होगा सर।
बस इतना मुश्किल है सेम बात को बोलना आपके लिए? हाँ चलो, ओके, थैंक यू, गुड नाइट।
थैंक यू सर, गुड नाइट।
सर।
थैंक यू सर।
थैंक यू सर, गुड नाइट सर।